What if we added something to x instead of multiplying, like 5? What happened? The graph moved 5 units to the left. And look what happens if I subtracted 5 from x. The graph moves 5 units to the right. So that tells us, this gives us our horizontal translations. Okay, so this lets us know, and I'll just go ahead and just type this, that that if you subtract, if you have a minus there on the C value, I guess it would have been better if I made it C. But if C is positive, the graph moves to the right. If C is negative groups of graph, we're going to say that's a right transformation. Boy, did I stumble there. And then if we got a plus, then that's going to be a left. So these are horizontal translations. So, all right. So you can see this really easy probably if I made it like, let's make it general. Like what if I put a C here and I put a plus? See there. See, and I make it a slider. And see, notice what happens when C is positive. When C is positive, the graph is moving to the left. When C goes negative, the graph is moving to the right. So that's what happens with the number that you either add or subtract from C. And then while I'm at it, let's also look at the last transformation, and these are all pretty easy. Let's just add another graph page here. And this time I'm going to put in F of, oops, I don't want to store verb. I just want to open one. Okay. Oops. Escape is your friend. Gets you out of trouble. All right. Oh, the reason why I was doing that because I did that. All right. So let me borrow F one more time. And first of all, let's graph F. Let's get F back up. Get our parent function back up one more time. And now we want to look at this transformation where we're talking about F of X. And this time I want to deal with outside parentheses. What if we add a number to the whole function? Like that. All right. I don't want to use C. We've already used C. Let's use D. All right. Boom. And I create a slide for D. Notice that, and came out in orange. Notice what happened if I add something to D, to the function, and it's positive, the graph is moving up. And if I subtract something from the function, the graph is moving downward. So that is our vertical translation. So if we got plus, that's going to be up. And if we have a negative number added to the function, then we're going to have a downward translation. So that is all of your translations. So let's review all the translations when you deal with this. We notice that the negative sign here lets us know that we have a reflection. All right, the negative sign by itself lets us know that. So I'll put an arrow right there. Okay. Ooh, that doesn't look like an arrow. Let's make it look like an arrow. That's better. All right, there. Okay. The A is our vertical compression. If A is between 0 and 1, then we have a compression. The graph gets wider. And if A is bigger than 1, then we get a compression. We get a stretch. So A controls these two. Okay. All right. I really one arrow would have sufficed. Let's see. There. Then let's look at, of course, let's look at B. If B values control our compression and stretch also, but from the horizontal direction. Really the main thing you want to worry about is that if B is negative, the graph will be reflected about the y-axis. So all this has to do with, let's use the negative and positive for the reflection, and we'll use the B for the compression. There. And then same thing with C. C controls the left and right. So they'll go ahead and pull this over here and right. And let's put some arrows there. So if it's plus, then we're doing left. So I'll just put it right there. Okay. And if it's negative, the graph is moving to the right. Right. And then same with the vertical compression, vertical translations. If D is negative, if there's a minus sign in front of it, then we're moving down. And if D is positive, then we're moving up. And that is all of our transformations of f of x. Let me